Nicotine is known to affect our body in many ways. Some of these effects include elevated moods, enhanced memory, increased attention, and heightened alertness. To understand these effects, we need to start at the acetylcholine signal transduction pathway. Acetylcholine, or ACH, is a neurotransmitter found in cholinergic neurons. Cholinergic neurons are located in the basal forebrain or in the brainstem. It binds to two cholinergic receptors, nicotinic acetylcholine receptors, known as NACHRs, and muscarinic acetylcholine receptors, or MACHRs. NACHRs are ligand-gated ion receptors, and MACHRs are G-protein-coupled receptors. But for this pathway, we're only focusing on NACHRs. NACHRs are found in the peripheral and central nervous system and are both presynaptic and postsynaptic receptors, meaning they can fire signals and receive them. Two ACH molecules bind to an NACHR. Upon binding, the receptor goes through a conformational change, opening an ion channel for sodium, calcium, and potassium ions to pass through. After that, the channel closes and the receptor momentarily goes into a state of desensitization, which is when ligands are unable to bind to the receptor. However, the receptor usually goes back to a state of rest where the channel is closed and the ligands can bind again. The depolarization activates voltage-gated calcium channels via action potential, which causes a further influx of calcium ions. The calcium ions act as second messengers, initiating synaptic transmission of different hormones and neurotransmitters. These include the release of glutamate, gamma-aminobutyric acid, or GABA, dopamine, ACH, norepinephrine, and serotonin. Now back to nicotine. Nicotine is found in tobacco, and one major tobacco product, which you've probably heard of, is a cigarette. When a person smokes a cigarette, they inhale the smoke and nicotine goes into the lungs. From there, it is absorbed into the bloodstream, crosses the blood-brain barrier, and reaches the brain. Nicotine then competitively inhibits acetylcholine by binding to NACHRs. Nicotine then mimics the actions of acetylcholine. NACHRs found on dopaminergic neurons release dopamine, which stimulates the reward pathway and gives you the feeling of pleasure. The release of glutamate and GABA both reinforce the effects of nicotine by releasing more dopamine through dopaminergic neurons. The release of acetylcholine actually contributes to enhanced cognitive function like memory and attention. Norepinephrine release is related to heightened alertness and arousal. Finally, serotonin being released causes a mood boost, anxiety relief, and better focus. The desensitization state, which occurs after the ligand unbinds, is not permanent unless in the case of continuous exposure to agonists. For example, smoking cigarettes often will lengthen the desensitization state, resulting in long-term inactivation. This builds up tolerance to nicotine, which causes the brain to add more of these receptors, resulting in withdrawal symptoms and craving.